In this video, we are going to use graphs to solve equations and inequalities. So there are pros to this lesson. As you'll see, it's really nice to have a visual of the answers that you're getting. And these types of answers are really quick because it's just a quick look at the graph. The con is that we're going to be having to approximate a lot of the answers. So if exact answers is something that is important, solving by graphing is not the way to go. So to solve a polynomial equation, so these look like polynomial equations because we see a polynomial and an equal sign. This is the graph of negative 4x to the power of 4 and so on. So first of all, right off the bat, you see that this method is only useful when you're already given the graph, because having to graph this would take us a fair amount of time. Our graph would not be as accurate as this, and then our answers, which already we're going to have to guess them, would be even less accurate. Okay, but when this polynomial equals 0, I mean, those are just the x-intercepts. So we can see that it hits the axis, I think, 4 times. That one's even hard to see. So we'd say around negative 3.5, around negative 2.3, around negative 0.1, and I think that last point looks like it actually hits when x is 0, but it's pretty hard to tell. To find when this polynomial equals 10, draw a line at y equals 10. And then find the 2 points of intersection. So here and here, and those corresponding x values would say are about negative 3.2 and negative 2.8. I'm pretty approximate there. And then finally, when does this polynomial equal x plus 5? So we have to draw the line y equals x plus 5. So it has a y-intercept of 5 and a slope of 1. Okay, so a ruler is really important here. But we can see there are 2 points of intersection. So here and here. And those x values, this is all so steep. Those x values are at about negative 3.4 and negative 2.5. Okay, so the answers are quick, but they are approximate. So what happens with a linear inequality? So this is a linear inequality because we see an expression with degree 1 and an inequality sign. So the first one is asking, and I've drawn the graph of 3x minus 1. So when is this graph less than 0? You know this in terms of negative intervals. That's from Unit 1. So we can see when this graph equals 0. It looks like about a half, but also I could do this pretty quickly. It's a third. We can see that point. And this graph is less than 0 for all your x's up to a third. So from negative infinity to a third. Okay, and we're using a round bracket here because we're not finding when it also equals 0, just when it's less than 0. So to compare this graph to negative 4, we will draw the line at y equals negative 4. Note that they intersect when x is negative 1. And then this graph is greater than negative 4 for all the x values after negative 1. So negative 1 to infinity. And this is a square bracket because we also want to find when 3x minus 1 is actually equal to negative 4. So now we are comparing this line with another line. Let's graph this line, y equals minus 2x plus 4. So intercept at 4, slope of negative a half. Use a ruler. Okay, so we can see these two lines intersect when x is 1. And when is this line, 3x minus 1, less than the line on the right? So all the values to the left of 1, the line negative 2x plus 4 has y values that are greater. And then after 1, 3x minus 1 has y values that are greater. So 3x minus 1 is less than 2x minus 4 for all the values up to 1. So from negative infinity to 1, and it can be equal to, so you'll see a square bracket. Okay, so what you're looking for is the point of intersection, and is the inequality true before this type of interval or after the point of intersection. So before point of intersection, and this is true after the point of intersection. All right, what about double linear inequalities? So a double linear inequality is when you see a linear expression sandwiched between two inequality symbols. I've graphed the linear expression 2x plus 5. When is this expression between 3 and 17? So draw a line at y equals 3 and y equals 17. And you can see that the y values of 2x plus 5 are between 3 and 17. What's that? Oh, down here. From negative 1 until 6. Okay, and we want it can be equal to 3 and it will be less than 17, so I'll use a round bracket. Okay, to compare this, we need to draw two lines. So the first line is negative a half x. So that means an intercept of 0, a slope down 1 over 2. Ooh, look, there's our little point of intersection. And we can do this in parts. So they are intersecting at negative 2. And the line 2x plus 5 is greater than 1/2 x from negative 2 on. So we can start our interval from negative 2. And then until when is 2x plus 5 less than x plus 6? So that's an x-intercept of 6 and a slope of 1. Okay, and we see pretty quickly that that intersects at 1. And this graph of 2x plus 5 is lower. The y values are smaller up until 1. And so the interval will end at 1. So it's okay to look at this in parts. When is this statement true and when is this statement true to create your answer? That's an interval. For polynomial inequalities, so note that f at x is degree 3 and g of x is linear. Okay, so we know which is which. Oh, sorry, they were labeled there already. Anyways, it can't hurt to just orient yourself a little bit. So when is f at x, the cubic, less than g of x? So as we go along our x-axis, g of x has points that are higher than f at x. So f at x is lower from negative infinity until this point of intersection, which is just past negative 8. So let's say negative 8.2. Okay, and then until our next point of intersection, g of x is greater. And then until our next point of intersection, so to begin with, g of x is greater, so f at x is smaller. Then f at x is greater. Then we can see f at x is smaller. So now it's smaller from, what point is that? About negative 4 to maybe negative 0.8. Okay, and then for the rest of the graph, after that point of intersection, f at x is bigger, so not smaller. Okay, then what about when it's greater than or equal to g of x? So when is f at x above? So we said it was above from, what did we say, negative 8.2 to 4 to negative 4. And it was above again from, and that's going to be square 0.8 to infinity. and it's square because when is it greater than or equal to? So that was how you can use graphs to solve polynomial equations, linear inequalities, double linear inequalities, and polynomial inequalities. And there's, in a way, a slightly different strategy for each. Just give it a lot of practice. Thanks for watching.